Program correctness, which part would you like me to go over? The loops, okay? For program correctness, let me see this. Okay, for program correctness, and you said about loops. Okay. If you want to prove the correctness for the loops, so first of all, you must have invariance and also variance, right? Okay, invariance is always a Boolean expression, and also variance is actually an integer expression, which should always maintain, which should always be larger than or equal to 0. Okay, so that's about the loops. Okay, that's about syntax. So before we talk about this particular lecture about program correctness, you learned about the basic syntax for loops. You got from, you got until, you got loop, you got end, right? And now the parts that you have to include in order to prove correctness would be the invariance and variance. Of course, there could be different cases where we might give you an invariance in the exam, and we want you to tell us whether you get loop invariant violation or not. Or we might give you a variance, you also want to tell us whether you're going to have a loop variant violation or not. Or it could be that we simply give you empty stuff, come up with the loop invariant or variance. Okay? Which part specifically would you like me to go over for the loops? Any parts in particular? How about we do, okay, we can do one example, yes. Okay, so now let's say a very simple example. Let's say this one here. Okay. I tell you what, this is actually the wrong version, okay? I'm not sure if Jonathan actually went over the same example, but the same idea. So now, for those of you from section Z, have you seen this example? You haven't, right? Okay, might be a nice test for you. How about that, okay? For section N, you can also try to just quick review. I want you to consider this particular feature. Let's say we're trying to find out the maximum, okay, for the array. Okay, you give it an array of integer, you want to return just the maximum. Let's assume you got at least one element in the array, so it's not empty. Let's assume. And then you simply say loop counter I is initially lower, and then it's simply assigned to the first element to begin with. And then inside, you will say that you will exit as soon as the I value is strictly larger than upper. And also you say that if the current element I'm looking at is strictly larger than result, that means I have to update the maximum. And then I gotta make sure I increment I every time. So now, if you look at that over here, the loop invariance we have is this. Okay, that's a loop invariance. I'll let you stare at that for a moment. And also we got loop variance, which is this particular integer expression. And finally, I want you to look at this particular post condition. Okay? So the blue ones are the contracts you have to give for the loops. And the first blue one is a loop invariance. That's for you to prove the correctness of the loops. And the second blue one is a loop variance, which is for you to prove termination of the loops. So both are important. And the green one is actually the post condition. And the best practice for you to really prove correctness is to make your loop invariance very alike the post condition. For example, if you look at that, let's say this guy and this guy over here, right? This is the post condition, right? And this guy here is the loop invariance, okay? If you look at them, they're basically the same. What's the difference here between the blue and the green? Yeah, exactly. One is A dot upper, which means we go until the end of the array. And the loop invariance say I only go until I. Conceptually, you can think about, let's say, if this is the array I'm looking for, A dot upper is pointing to this particular element over here, right? If I already reach this particular element, I have considered that, that means I'm done with the entire algorithm. But now if I'm still somewhere in the middle, let's say this is I, that means the maximum I've found so far is only for this particular subarray, right? I want to go such that I will eventually cover the entire array. That's kind of the idea. Okay, good. For section Z, how about we test your understanding? Tell me something, whether or not the loop invariant over here is correct or not. The loop invariance there. And of course, just for your information, this particular blue loop invariant over here corresponds to this predicate logic notation here. For the exam, you are expected to know both how to use across and also how to translate it into practical logic and vice versa. Okay, just to mention. Anyone want to say why or why not this particular loop invariant is correct? Oh, dot? Okay, you can think about, okay, I think I might have a slightly different notation as Jonathan, so pretty much the same. So when you have a vertical bar, it means such that. Such that, between the such that you're trying to specify some range, you want to say the j is between a dot lower and I, right? And the dot over here is to say it is the case. So for universal quantification, we simply say for all the j that's within this particular range, it is the case. This particular properties holds. Right? Okay, so now, question. Is this loop invariance correct or not? We got even more questions. Yes, go ahead. You don't think that's correct, right? That's okay. But we actually went through that last Friday, right? So let me give section Z an opportunity to practice. Well, if you do believe it is correct, give me an informal account why you think it is correct. If you don't believe it is correct, that means we might run into maybe loop invariant violation at some points. Then why not? Why would that be correct, right? And this can well be some type of question we can ask you in the exam, right? You want to judge to see whether your contract is appropriate or not. Anyone? Yes. Okay. Let's see this. Okay. Okay. So you believe it is incorrect because when the array is empty, but we assume the array is not empty, right? So that's not an issue. We assume the array is not empty. But you want to explain? Okay. Wait a bit. Okay. Just want to give it. Yeah, Ben. Mm-hmm. So what are you claiming? You're saying it's incorrect because?
On the last iteration, it goes from I to A dot.
Mm-hmm. Okay, and then?
The range from A dot lower to I doesn't exist.
Okay, you're basically saying this. It's actually valid points. But what you are saying is, because we know that we started with I to be a dot lower to begin with, right? Let's give one example over here. Let's say if this is the array we have over here, let's say 1, 2, 3, 4. And in the exam, we're going to assume the lower index for the array is always 1, unless we otherwise specify to be something else. Okay? Let's say I is initially just to be 1. And now the question is, since we are trying to increment I at the end of each iteration, what will be the final value for I? Let's say we go all the way until the end. Should be I plus 1. Sorry, the a dot upper plus 1, right? In that case, that would be 7. What you're claiming is, for this particular example, I would just be 7 when we try to check the loop invariant for the final time, right? After the final iteration. In that case, j being 7 will be used as an array index, and you'll get array index out of bound violation. That is true. However, it is likely you might get a loop invariant violation even earlier, even before you get to that point. I can see your point. That's also valid. Anyone from section before I call you for explanation? Okay. How about I give you a little bit hints, okay, just for section Z to help you think. So what I would like to do is, can we look at this particular array, just for this particular one? 20, 10, 40, and 30. Indices 1, 2, 3, and 4. Let's say this. So now, if you try to run this particular array, are you going to demonstrate that the loop invariant is wrong?
So when we get to the number, it's because we haven't updated yet, so our invariant is wrong. We should put the order of I and then the statement so that one.
You want to explain again? Okay, I think you're getting there. Yes, just try again.
It's because that
Maximum you meant.
Oh, yeah. Our loop variance is going to be wrong.
Mm-hmm.
So it's better if we just put the two segments in the loop to make sure that every time we increase it, we'll check it. So the loop variance is going to be true or no.
Okay, so now in this case, of course, every time if you got something wrong with the looping variant, you can either fix the implementation or you can fix the looping variant. Let's say in this case, we don't want to fix the implementation. It's actually fine. It's a very standard way of doing things. Okay, but that's good. Let me go a little bit further to your thought. I'm going to repeat. That's exactly correct. Let's say we don't allow you to fix the implementation. How would you modify the looping variant so that it's not going to become correct?
I minus 1 is being considered I plus 1 case.
Okay, very good. So now for this particular case, okay, I tell you what's wrong here. From this diagram here, for section M, I'm just trying to present this in a briefer way as we talked about from last Friday. You can refer to lecture recording to have a more detailed view. Let's say this. For the very first iteration, we're only going to consider this particular elements, agree? For the very first iteration, right? And in that case, the maximum is going to be 20, right? Now what about after the second iteration? If we finish the second iteration, that means we have considered these two elements in the array, and the maximum still remain to be 20, okay? So now, here's the problem. Because the maximum remains to be 20, however, the I value over here is actually going to be the I plus 1 that we did from the previous iteration, which means you will also consider the 40 over here. Right? You see what I mean? Okay, that's really the problem. If you, for those of you who are interested in knowing more, okay, let's say this. This table is a little bit boring to trace. Okay, my point is, if you actually say I over here, the I value over here actually comes from the I plus 1 that we did from the latest iteration. Okay. However, this particular latest value for I indicates some value which has not been considered just yet. It's actually going to be considered in the coming iteration, but has not been considered yet. So as soon as you can see from the table, you can try it out as well. As soon as you get to at the end of the second iteration, okay, at the end of the second iteration over there, you actually have the maximum remains to be 20. However, the value for I is actually 3, right? In that case, in the index 3 will actually cover all this particular array. In that case, the maximum is not 20 anymore. It's actually 40. Okay, so that's why you're right. How do we fix this particular one? You can simply say rather than I, you can fix that to be I minus 1. Okay, and for section Z, I do have a question for you. Okay, now if that's I minus 1, right? What's going to happen if we try to check the looping variant for the first time? That means we're checking it even before the first iteration, right? What's going to happen? Index out of bound? No. Aha, exactly. Yes. It'll be true trivially, right? Okay. It will be true trivially for the following reason. So let's say after the initialization here, we know that I is simply just going to be 1. Okay. And then, so what we have, I will simply just be 1. And now let's assume that we already got a fixed version over here, I minus 1. So we're going to have for every j such that a dot lower, and we know that it's just going to be 1, less than or equal to j, and then less than or equal to I minus 1. In this case, that would just be 0. So that means for this particular range, it's simply just empty, false. Okay? As you learned back in 1019 or 1090, if you got for all quantifier for all x such that simply false. And then it is the case that any predicate x, this will just be trivially true. Okay, intuition is because for the empty range, you cannot find any violation case, so that's why it must be true. Okay, it's a very quick review. Let me go a little bit further just for the loops. But this one here, just quickly review between looping variants. And now what about variance? Do you think the variance is okay right now? So what's kind of the healthiness conditions for loop variance? What are the two healthiness conditions? Anyone want to try? What are the two healthiness conditions for loop variance, integers? Anything? Anything? Okay. But you got to review this. This is important, right? Anything I try to remind you about, you better review them too. Yes? There are two things. Yes? Okay, good. So the first condition is, so there are two things about loop variance, right? Number one, the variance you have must be larger than or equal to 0 for sure, okay? At no time should you ever get into below 0. Number two. It cannot be the same value. It has to decrease or increase. Which one? Decrease or increase? It matters. You cannot keep increasing, because if you keep increasing, yeah, but the way, well, since we talk about Eiffel specifically, right, the way they check at the runtime is to say, yeah, you may have a maximum bound. Let's not get too that complicated, right? You can just say start with some value that's positive. You go all the way towards 0, right? Okay, number two is the latest value, the loop variance for the current iteration must be strictly larger than the one from the previous iteration, right? No, the other way. It should be strictly decreasing, so it should be strictly less than. Okay, that's also one of the conditions you gotta prove, right? So these are the two healthiness conditions. Do you think the current loop variant is gonna satisfy them? You think so? Okay, I agree. That one is gonna satisfy. However, let me give you a quick counter example. What about this guy here? How? When? Yes.
Well, I has the exit condition is I is greater than a dot upper.
Yes.
At most, I is going to be a dot upper plus 1, and that will make it negative.
Yes, exactly. Because as soon as you're ready to exit, so satisfying this basically means I would be exactly a dot upper plus 1, according to our way of incrementing the I. So now a dot upper plus 1 is going to, if you substitute it inside, you're going to get exactly minus 1. So that's below 0. So it violates one of the healthiness conditions. Okay? Another way to do it, now this is kind of one of your most common mistake back in 1021 or 1021 or 1022. Right? Now if I, let's say, get rid of this, let's say even if I fix, so this is wrong. If I fix that to be a dot upper minus I and plus 1, right? That'll be the correct way, okay? Let's say I change to this correct loop variance. So now it's guaranteed, it's always going to be non-negative. But at the same time, I got rid of the last line in the implementation. Are we going to be okay? Apparently, if you just recall from your 1021 or 1022, it simply wouldn't terminate ever. But now you can see from another angle why it wouldn't terminate. Because the loop variant that we use to measure the progress is not going to change ever. Always remain to be the same value. Okay? So just a quick review. And then we also get things like this. Let me just show you. It's pretty much the same slides as your section. Pretty much the same. If you want to prove the correctness for loops, so there are two things you got to prove. One is about termination, right? If you want to prove the termination, you got to prove the two healthiness conditions that we talk about. And of course, you don't have to memorize the rules. Feel free to put these rules on the data sheets you're going to bring on Friday, okay? And also, you want to prove about, assuming that it's going to terminate, we want to prove partial correctness. In that case, looping variance is established. Also, looping variance R is maintained. And also, at the end, looping variance also exit condition is true. That means we exit from the loop. That should really imply the final post condition, right? These are the three. Yeah, I do have the example for you to actually prove the various conditions. You can try. Okay, I do have a solution for the trickiest one. You may want to practice for that. Okay. Yes. Oh yeah, in order to prove that the loop is partially correct, you have to prove all the three, one by one. So in the exam, we might say the following. We'd say, okay, now given the looping variant for this particular loop, and given its implementation, now proof number 2 over there, which is to say at the end of each iteration, you're going to maintain the looping variance, right? We'll be clear what you have to prove. So for the program correctness, I would suggest you put the following on the sheets. Number one, you should put all the WP rule, right? WP rule for assignments, for alternation, for sequential composition, etc. Also, you want to put the proof rules for, and also the loops on the paper. Hopefully, you don't have to refer to them too often. That's a bad sign, actually, during the exam. Okay, but you will be required to do some proofs in the exam. Okay, any questions? Yeah, I hope that's answered your question, right? Okay. Any other questions? Yes. Agents, okay. So two things about agents. Number one, we talk about two agents in two occasions. Occasion number one, when we talk about event-driven design, you can use the agents just as a way to store delay execution for the update events, right? For each forecast, current conditions, or the I forgot what the third one is. Anyway, we got three different observers. For each one of them, you got a particular update function. You can store their reference using agent. That's one way you have to know. Okay. Number two, which we cover, let's say for section N, we covered that last Friday about how you can use the agent to define the hold count, the counting quantifier. That's also something you need to know. Okay. Yeah. But you can study that and then let me know what questions you have, right? Yeah. Unless you want me to go over the whole thing again. The important parts. Okay. How about this? I would suggest, let me launch Eiffel Studio quickly. Maybe I wouldn't Yeah, the exercise, you can try it out, and then you can maybe show me the answer. Yeah, for that exercise, I would say that might be still too complicated for some people here. I would say rather get the initial one correct first. Okay, understood. Okay, so now for this, let me just go over the counting very quickly. Okay. Okay, let's think about what we're doing over here. Okay. Basically, this is what we have. Okay, let me try to maybe program from the paper. Let's see what we can do. Let's imagine that we have a util class. Okay, we got a class util. Okay, and let's say that should be big enough. Okay, util. And then let's have a one feature over here. Let's say it's called, let's say, any Boolean predicates will be okay, which means take some integer, returns a Boolean. Let's make it easy. Let's say is positive, let's say. Okay, let's say simply just going to take some I of type integer, and then it's going to return a Boolean. Okay, let's write it down. And over here, you can simply say result is assigned to I is strictly larger than 0, right? It's very easy. So this feature, this query over here, our purpose is we don't really want to execute it right away. We want to store its reference so that it can be executed for many times in a reusable fashion. Okay, let's see exactly how it's going to happen. So now what we're going to do is we're going to have another feature here. Let's go counting. Okay, let me just write down the signature first. The counting is going to take an array of integer. Okay, I'll just say int. And also, it's going to take another one. Okay, let's call it function. Okay. So function is simply a predefined library class in Eiffel. So when we talk about event-driven design, back in the observer pattern, so we used one called procedure. Procedure is simply that means it's some feature that does not return anything, but function does return something. That's the only difference. Okay. So now if I say function over here, and then let's say it takes an integer and returns a Boolean. Okay, like do and end. Okay, let's pay attention to the signature here. The first one is simply just a. And the second one is just going to be a function. Okay, let me just, I forgot to put one more thing. Let's call it f of type function. Okay, so now function over here means any feature that takes a parameter. Okay, this is a parameter type. And this is the return type. So now any function that takes an integer and returns a Boolean is proper candidates for calling this particular function. What can be a proper candidates? Exactly, right? You can see it takes one integer, returns a Boolean, okay? But we're gonna see exactly how we can do this, okay? We're gonna see that, okay? So what we'll do is let's, before I fill in the body for this particular feature over here, let's just see a test quickly, okay? So now I'm gonna bring up another class over here, okay? Let's put it here. Okay, let's say we have an ES test, and then we simply get, let's say green. Let's say we have a test. Let's have some local variable as well. So we have local variable over here. So now we simply get, let's say, a, which is an array of integer. Okay, let's do a very simple test. Let's say a is simply assigned to this particular array. Let's say 1, 2, 3, minus 1. Okay, that's the array. So we do not have all the numbers being positive, right? And then let's see how we are supposed to call this particular counting feature. I do forget to put one more thing. This counting here is going to take two inputs, and then it's called counting. That means it's going to count how many numbers, right? It's going to return an integer. I forgot to put it, okay? So now let's try that. If I say result, so this is our test. So the test is also going to be a Boolean. So I can say result is assigned to, I simply just want to call counting. Also util. Can I just make this expanded? You guys remember what's special about expanded? Yeah, you don't have to initialize it, right? Expanded, right? There's no reference to it, just the whole thing, right? Don't forget to review expanded. That's also important. Okay, so now if I declare, let's say, u over here, just util, that means I don't have to explicitly create it. It will just be initialized. So now I can say u dot counting over here. So now I'm expecting two arguments over here, right? Two. The first one is easy. I can just pass a, which is matching array of integer. Okay. What about the second one? Well, the second one, would it work if I say the following? The second one, I'm running out of space. I'll put it here. Would it work if I simply say u dot is positive? Okay, I heard no. Why not? In a reference to it, think about what's happening over here. If you do u dot is positive, what's going to be the type for this expression here? It's a Boolean, right? However, if you try, what are we expecting over here? We are expecting a function, not an integer, right? So that means the correct way to write it would be you have to use the keyword agents. Okay? And one more thing to say. It's positive, it's always expecting an integer, right? So now you got choices. You got choices. Okay, I'll show you both. Okay? Let's do some funny way. Okay? If I simply say, you know what? Let me move this a little bit. If I simply say it's positive, if I simply say 2, it is going to compile. Okay? However, what's going to be the result? Well, it's going to be true, right? That means it's going to be, okay, I'll tell you exactly how the counting is supposed to work. The count, let me finish the, okay, let's leave this part here just a little bit over here. Okay, I'll come back to this. The way counting should work is we basically want to go over, let's say, this particular array. I will put it down here. So 1, 2, 3, minus 1. We basically want to go over element by elements over here, element by elements. For every element we are encountering, we want to really call this particular, for example, is positive function. Any function that is going to take an integer as arguments, and the integer here talks about exactly what each element is, right, in the array. Call the function on every element there and get some Boolean result over there. And the counting is going to count how many of them is going to evaluate to true. Okay? So now, let's see, how do we write this code? Let me write it down first. Okay? I'm going to say across, right? You can just say across A as cursor. Okay? Feel free to write in the front until loop. That also works. That's fine. Okay? And now I can say, let's say A.item is going to be a particular element of type integer. It can be this guy here. It can be this, or it can be this, right? Either one of them. Now it would be a very suitable candidate to call the function. So now, how do I call it using f? I can simply say f, just like how you write in math, right? F calling A.item, and now I want to say if this particular thing is actually true, then the integer result is going to be incremented. Result is assigned to result plus 1, end. That's it. Very easy implementation. Again, the idea really is the counting is going to take one array like this, and then it's going to go over every element in the array. If I'm currently looking at this particular element, I'm going to pass that element there as the input to the function over here and see if that's true or false. If it is true, increment the counter by 1. Otherwise, don't increment. Okay? So now I have a question for you. Okay? Given this particular implementation over here, if I simply got currently result is assigned to u.counting at pass A, and I pass agents, okay, agent over here, u dot is positive, but now I give 2 over here, okay? So now, what should be the value over here? Again, what's that? 4, why not 3? We only got 3 positive integers in the array. It is always true. Can everybody see it? Let me, before I explain, let me give you another example. What if I try the orange one? I say agents over here, u dot is positive. But now I'm going to put minus 2. If I do this instead, what should I put over here? 0? Because it seems like for this particular call, right, I'm storing basically this particular call, which is always going to apply minus 2, which is going to return false, right? That means when I actually try to use this particular element to pass into f, there's no effects because this particular function is going to ignore whatever the array element is. It's always going to use minus 2 as the function arguments. Okay? So in this case, it's just going to be 2, and in this case, it's going to be 4. Both are bad because you're kind of ignoring the array element you're trying to call, right? So now, how do we fix it? That's a problem, right? So this is something I reviewed last time. It's about partial application, right? What you can do instead. So this is the correct way of doing it. Okay, let me put it here. You should say agents over here. U dot is positive. So now when I store the reference for this particular function, I'm not committing to what element it's going to call. It's going to apply. I'll just put a question mark. It's called open arguments. Okay, if I do that, now, if I do that over here, so now what's going to be u.counting, and then I pass this particular one. What should be the result? What should be the return value for the counting quantifier? 3, right? It's going to be 1. In this case, the first time is going to say, is positive 1? Yes. Is positive 2? Yes. Is positive 3? Yes. Now, this one here, no, right? So now it's going to reflect exactly. So in that case, it's going to be 3. Okay, question about this. This is something very important for the exam. Okay? If you are stuck at any points in this illustration here, just tell me. Otherwise, I'm going to assume you're okay. Yes? Sorry, say it again? Oh, yeah, you got to say loop over here, right? Maybe that's what you're talking about? Cursor the item, of course. Thank you. Absolutely. Yeah, be careful when you write in the exam. Yeah. Guys, are we okay? That's about the agents. Yes.
Suppose this positive took 2 parameters.
Yes.
How would the function change in calculus?
Okay. If you got 2 elements in the array, let's say 2, okay, let me start a new page. Let me start over. Let's say I still got this class over here, class util. Okay, and then let me see what can be interesting. Okay, how about we do this? Class util. I'll just give you one example how this can be manipulated. Okay, so now let's say I will have one simple query. Let's call add, addition. Add is taking I and j of type integer, and then it returns an integer, right? And you will say do and end. You will say result is assigned to I plus j. Okay, let's say that. So now, if I go back to question number 1, given this, does this particular add feature over here, does it satisfy the signature over here? No, right? That's good. That's number 1 to recognize. Very good. Okay? Let's say we do want to use it, let's say. Let's say eventually we want to have something like this. Okay, just for fun. Let's say we have an array like this. Let's say 1, 2, 3, 4, 5. And then we want to do a particular way of sum. Let's say indices 1, 2, 3, 4, 5. Okay? Let's say we want to get 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4 plus 5. Okay, let's say we want to do that. How can we achieve this using the counting? Let's say, well, I'm going to show you, of course. Okay, guys, you know what the problem is? I'm just modifying to show you the variance. In the exam, you're not given exactly the same thing as I just talked about. So that's why you want to really understand what's going on here. Okay, so you can solve different problems. Let me say that again. In the second example I talked about, it's going to be very similar to the one I just talked about. But now I'm changing the function I want to store its pointer for. It's going to be taking 2 integer arguments rather than 1. Okay, number 1. And also it's going to return just integer rather than returning Boolean. What types you want to return is completely up to you what you need for your application. Okay? So now let's say eventually what I want to do is, given an array like this, I want to sum up the elements in this particular way such that all the middle elements over here will be counted twice. Okay? But the beginning and the end, they also counted only once. Let's say that's what we want to do. So now how do we do that? So now let's do counting over here. And then, so now let's say A is of type array of integer. I'll say A of type integer, okay? And now I also got, let's say, F, and also function. So now take a guess. What should I declare in order to match? Int and int, right? Exactly. It's as easy as that. Yeah, it's not hard, okay? You would say integer, integer, and the last one is simply return type integer, okay? And now we say do and end. I'm going to fill this in just a little bit later, okay? So now let's see a very quick test. If I say test, which is going to be Boolean, again, I got local over here, A of type array of integer, okay? And then do. And of course, I can also got util, U of type util. How do I code in this particular test case? I can say A is simply assigned to 1, 2, 3, 4, and 5. Okay, and then I can say result is assigned to. Now I can say util.counting. Now, what should I put? Help me out. A, okay, that's easy. What about second one? Agent, okay, I agree. Okay, and then let's say add, right? U.add, okay? U.add. So now, of course, you got many choices. You can be as wrong as 2 and 3, right? That's not good, right? You don't want to fix any one of them. Okay, apply the same idea over here. What should I put? Question mark, exactly. Question mark means the following. I'm storing the pointer to this particular integer function. However, I'm not committing to what the first and second argument should be. It will only be decided when I try to call that later for the delayed execution. Okay? So now, what should be the value for that? Equals, well, let's try it, right? 3, 5, 7, and 9. 24? Okay, let's say 24 is the one we want to get, right? I'm just trying to do the sum. So now, can you imagine how we're going to implement the modify the counting accordingly? Maybe a cross loop would not work anymore, maybe, right? Somehow you need to grab 2 elements in the array rather than just 1 element, right? The way I set it up, just to make it easy for you, how will we do it? You might need a from loop.
Can we do from the lower bound +1 and -1 to instead of sending 1 into
Yeah, power of 2. That sounds a bit too much. You're getting there, okay? You definitely want to add an op. You definitely want to. Anybody want to try? Okay, you talk about cursor.item and also cursor +1.item. It might be a little bit too much influenced by the C, pointer arithmetic, right? For the pointer, you can say +1. Yeah, but I'm just saying you cannot do such syntax, in Eiffel, right? Don't do that in exam, okay? Yeah, exactly. You need a from loop. That's my point. Using the across, since we don't support pointer arithmetic in Eiffel, so you don't want to use a cross loop. Let's use a from loop. Yes. Okay. Let's say we use a from loop. So now let me start it up, and then you can help me out. If I say from, you know what? Before I do that, let me declare the local variable first. Let's say we got local over here, I, integer, and do. Okay. If I say from, I is assigned to a.lower until. So now, until you want to be a little bit more careful. Okay. Right. Remember, well, we want to be as simple as possible. Somehow, you don't want to count the last element twice, right? You don't really want to. How about I put it up for you? What I'm thinking about is I until I is equal to a.upper. Yeah, good. You're getting there, right? Okay. And then, what should I do over here? Well, basically, I want to apply the f twice, right? I can simply say f over here, and then actually once or twice, just once, but 2 elements from the array. So now I can say 8 at position I, 8 at position I plus 1. And this is going to be of type integer, right? And now I want to increment the result according to that. Result is assigned to, result plus. That'll be it. Any confusion here? Just tell me. Yeah.
Couldn't we still use a cross, but we use like a.lower and
Yeah, you can. Yeah, actually, you know what? I think because, well, I would say typically you use the across loop when you don't have to know about the indices of the current position for the across. You can definitely use across still, but it would be like it'd be not necessary. I would say in this case, you just use a from until loop. Does that answer your questions? Okay, guys, are we okay with this? It's just yet another example, right? The difference is, so now you want to be very flexible in your understanding. The function we want to pass can either be taking as many elements as we like, okay? And return type can also be arbitrary. And also the counting or counting 2, counting 3, whatever we want you to define, right? If we wanted to define the exam. You want to say it's a function over here, but now you're going to want to define this accordingly, right? And then the loop that you have to write also can be flexible, right? I'm just trying to show you a different example. Yes, first. From until loop, yes, yes. Yeah, guys, don't be like me during the exam. Yeah, what's this, really, right? By the way, where the question asks you to write in Eiffel syntax, we mean Eiffel syntax, right? Not Java, not Python, Eiffel, right? Yes, you first. I'll come to you. Yes. Yeah, good. You guys are very good. Yeah, of course. Make sure it terminates. You're gonna say I is assigned to I plus 1. Yeah. What happens if array is of size 2? Yeah. In that case, yeah, I agree with you. Yeah, that means you're going to be more careful. Yes, true. How about, let's say this. The counting, we simply say we assume a dot count, let's say larger than 2. No. I can do it. You cannot. In the exam, if there's anything you believe that's suspicious, we may not be able to answer you in time or broadcast the change. Document your assumption on the question, so we'll look at that. But of course, if your assumption is simply ridiculous, well, that's another story, right? Yes? Yeah, what does it do? Okay, what it will do is like this. So now let's review quickly. Sorry for the mess over here. Right? What it's going to do is like this. So when you try to make this particular call, right? So you're going to, first of all, you're going to basically store the reference for at, which is over here. And now I and j, we simply say we don't know what they should be. That's why it's question mark, right? And then when you execute the counting, the body of the loop, you're simply just going to go over the array A. Let's say this is A, 1 by 1. Let's say the first one, okay? When for the very first iteration, I will just be 1, right? In that case, we're going to have AI and AI plus 1, which are exactly these two elements. And then we'll pass these two elements into this function pointer and invoke that. And then that means it's as if we put 1 and 2 over here. And then you're going to do the addition, right?
So when you do the counting, when you pass an agent like that,
Uh-huh.
they have a new instance of that getting all graded like that.
So you mean
Since you just expanded.
it's expanded type, yes.
Yeah, so every time we calling the counting function, we creating a new
Or instance, you don't have to.
instead of add.
Yeah, so basically, I'm not sure if I'll try to answer, but I'm not sure if that's exactly what you're asking. So U over here is util, which is, let's say it's expanded, right? Let's be consistent with the previous example. Let's say it's expanded. So that means at a runtime, U is like this, right? It doesn't have a reference, just like a U. And then somehow it contains the definition for both the add and also the counting, right? They're just part of the objects. So every time if you just try to declare another one, let's say U1 and U2, and U1 is going to be this object here, U2 is just going to be another object, which got a separate copy of counting. Yeah. Yes, correct. So let me just repeat a particular part of syntax over here. So basically what you have over here, let me just write it down again, okay? Let's say you put it here. So you say agents over here, okay, that's a keyword, and also u.add, and then question mark, comma, question mark. That means rather than giving specific value for your argument, you just give question mark. It's a valid syntax, yes. Okay. Yeah, we're thinking this way. You only try to put question mark when you try to use agents. Okay. You mean for the loop? You know, I'm just trying to give you one example. You can feel free to modify the loop. But the idea is the way you iterate through the elements is completely up to what your application needs. So in the exam, if we do give you something similar, read the question carefully to see how the pattern of the loop. Okay, let me give you a quick summary. Okay, so for this particular problem over here, you want to think about several things. Okay, number one, what should be the pattern of the loop? Right, you can see this is one pattern where we try to get two elements, and this is just another pattern, right? It's a pattern of the loop. And number two, what's the signature of the function? Okay, in this case, you can see one case is function with int, and int. The other case, you got int and boolean, right? They're different. You want to be flexible. And number three, you want to know how to use the agent and also open arguments, right? Because, for example, you can see here we got agents and then u.add question mark versus you got over here u dot is positive over here, just one question mark, right? They're different, okay? But the idea is really the same. You want to store the reference to the function while you want to delay the commitments to the arguments. The arguments will only be committed when you actually try to walk through the loop in the counting. Okay, that's a quick walkthrough of this particular type. So this is one type. The other type would be how you do event-driven design, right? In the observer pattern lecture. Yes? What if the function has no return value? It's like a procedure. So let me mention quickly. So what you're asking is, so there are three classes you might want to use for this type of problem. One is function, right? Function, I'll give you one example here. It can be integer and also integer, right? And one possible matching type can be just add. And then I can say add 2 and 3, and also it returns 5, for example, right? Another one is called procedure. And procedure is something that we used in the event-driven design for the weather station, right? So that one, I'll give you one example. Could be you simply just say just procedure in that case, okay? You can take something. How about just take some let's say integer? It doesn't have any return type. It's always command basically for procedure, okay? So I can say updates. Let's say increments. Let's say increments by, and then I can put, for example, 3 over here. Okay? It doesn't return anything. Okay, one more, which you may not have seen. It's called predicates. Predicate is basically a special case of function. With predicate simply means a function returning Boolean. I'll give you one example here. So predicates, I can say, for example, integer over here. So when you say predicate integer, it's as if you say function, integer, and Boolean. It's as if you say that. One example could be, I can say, for example, it's positive, right? And then I can simply, and over here I can say 3. In that case, it will match this particular argument, right? I don't need to say it's Boolean because it's predicates. Okay. So these are the 3 possible classes you may want to use in the exam if we give you this type of problem. Okay. Of course, feel free to put it in the data sheets if you might forget. Feel free. Any other questions about here or any other questions? Yes? Oh, that's good. What is the weakest possible precondition? Section M? True. Good. Good. I'm proud. And What is the strongest possible precondition? False. Yeah, good. But notice that if the weakest precondition turned out to be true, that means it's very, very user-friendly, right? That means any input value could be good. What if the precondition is actually false? It's very useless, right? Nothing is going to pass. Right? Guys, any other questions? The ETF paper, yes. So both Jonathan and I, we mentioned that there's an ETF paper that you should read. Yes, you should read it, especially about the e-health system for the math model. We are not guaranteeing there will be a question on there, but there might be. So, right? You see what I mean, right? Yeah. There may be questions there, there may not be. Likely to be there, but also likely not to be there. Okay. Strategy pattern. Strategy pattern, you should read. I would say, I tell you what, strategy pattern is not there because we didn't cover that explicitly in section M. Only strategy pattern. Okay. But we might give you something that's actually a strategy pattern, but we'll just give you some context there so you can still solve it. Right? We didn't say strategy pattern and then we assume you know what it is. Right? Observer pattern, yes. You mean the whole thing or some part? The whole thing, sure. Why not? I'll set this up. Give me one moment. I'm recording, yes. I'm recording. I am recording, yes.
Would we be required to build like an entire pattern from scratch?
Okay, the question was, are you required to implement the entire pattern from scratch? No. But, for each pattern, this is what we expect you to know. Number one, you should know what kind of problem the pattern is solving. For example, if we give you some like an online booking system, you should immediately tell, oh, maybe I should use a multi-pattern or stay pattern. If I give you something like a weather station or maybe online evaluation system, right? You should know that it should be observer pattern, right? Something like that. That's number one. You should know what the problem domain is for each design pattern. That's the minimum. Number two, you should be able to draw design diagram for each pattern. Bond diagram. Bond diagram drawing is a very important part for the exam, I can tell you. But I'm going to go over the observer pattern case as well. You want to know how to draw, okay? Number three, you should know how to read diagram as well, right? If I give you, this is a potential design for observer pattern, is it good enough, right? You should read the diagram and see, okay. And number four, what about writing code? We wouldn't expect you to write everything from scratch. We might, for example, we might give you, I'll give you also example in observer pattern. We might give you, let's say for the multi-pattern pattern, we give you maybe the execute feature over there. We give you the signature. And now we say, now, implement this particular template feature in the following sense. I will give you the description there and then just do it, right? So you don't have to implement everything from scratch. The answer is no. But you will be expected to write some code for sure. I'll give you a more concrete example in a moment, okay? So now let's have a look at this. Okay, so now I will go back to observer. Okay, this is the general architecture for observer, right? That's something we went through before. Okay, let's have a quick look. The most important part is about you got two categories of classes, really. Okay. You have to draw a diagram. Of course you should. I'm pretty sure you missed something. Yeah, I'm pretty sure you have to draw a diagram. You can take my word for that. Okay? Yeah, diagram. When I say you got to draw a diagram, I'm not talking about single class. You may have to draw multiple classes. And then make sure you know how to draw a client supplier, how to draw label for client supplier, how you draw inheritance, and how you draw clusters, right? Things like that. Okay. You mean for the diagram? We will give you instructions on the exam paper. But I would say if we didn't really say how detailed you should really draw, since it's going to be a very big, in the exam center, we may not be able to answer everybody. I would say draw as much detail as you can. Yeah. Yeah. Good. Okay, so now let's look at, I think I'll use the observer pattern example to show you several things that you might have question about. Okay, so now for the observer pattern, we got two clusters. We got subjects, we got observers, right? Okay. And also we got subjects, and we also got observer, right? Oh, by the way, you should know what's the difference between plus and star, right? Okay, I assume you know, right? Okay, I don't even want to talk about it, okay? So now here, for the subjects, the most important, there are two features that's really important. Number one is observers, right? You got a list of observer, okay? So what does that mean? That means the static type for every element in the observer list is observer. So what does that mean? Dynamically, what can be the type for observer? Every descending class is over here, right? Okay, we'll go over that, okay? And also notify is something you should also know. We'll also go over that as well, okay? You can, for your particular application, you might have as many subjects as you like. You can also have as many observers as you like, okay? For the observer, the most important two features would be, number one, how do I update my attributes so that I can, well, thinking this way, it's not necessarily the case that every observer is going to observe all the information for the subjects, maybe only part of it. Okay, let's see one example here. So this is the general architecture. So this is the specific architecture for the weather station. Let's go over that quickly, okay? So now we got subjects cluster, we also got observers cluster, okay? So you got subject here, you got observer here, okay? And in this case, we only got one particular subject, weather data, okay? And we got temperature, we got humidity, we got pressure. So now, every observer does not necessarily have to observe all the three attributes, maybe only one or two or three of them, okay? For example, forecast only worries about the pressure, okay, to see if the pressure is decreasing. The current conditions only worry about the temperature, okay, and the statistics worry about maybe all the things, okay, temperature, humidity, and pressure, right? Depends. And let's see this. If you got observer here, you can see observer and the observer here, right? A very easy design question for you, okay? So we might give you the diagram here, and we say, now let's consider the following change. If I change this guy here, rather than observer, I change that to forecast, let's say. Everything will still compile, not an issue. But is this an acceptable design? Why not? Yeah, exactly, because, okay, that's exactly right, okay. Section Z, you want to say something? Why? Yes, you guys.
If you want to add more observers, you can. Like, you can.
Well, you can definitely add as many observers as you like.
Like, you won't make a difference.
What do you mean it won't make a difference?
You won't be looking at it. Like, you're only looking at
Okay, so now let me be more specific. If I change this to forecast over here, so why can I not store current conditions inside the list? Why can I not? It's different objects? Not exactly satisfactory. You want to be very complete, right? Think about when we talk about inheritance, right? When we talk about substitutability, we talk about types, right? Anyone want to try? We want to know how to justify, yeah. Yeah, something like that, okay? This is not a good design because forecast over here, so that means dynamically only, actually child class is not even good enough because child class means the class immediately below one level. You want to say descending classes, okay? Dynamically only descending classes of the forecast can be stored. Okay, this will be the A+ answer. Okay, if you miss some information there, maybe decrease to A to B+, etc. Okay, yeah. Well, that I'm just telling you our grading scheme, right? We're just trying to give you more help, right? Okay, let me finish this and I'll take questions. Okay, So now, of course, you should really use observer here. Okay, and now for the notify. Okay, the notify feature is actually very important to get right because notify there is going to illustrate dynamic binding, right? Let's have a quick look how the notify feature should be implemented. Anybody want to give a hint? Okay, let me put notify here. Notify and then do and end, right? I'm talking about this notify here. How should we implement it? So what's the purpose for notified? You want to update all the not really well. You know that the weather data has been changed, so you want to make sure all the observer that have been subscribed to this particular subject is kept up to date, right? How would you do it? Yes. Yep, that's exactly right. Yes. Okay, let me write it down over here. It's very simple implementation here. So let's say I can say across observers over here. Let's say S. Let's say O. Okay, for observer, and then I can do a loop, and then end. So now what should I write? Oh no, I already got cross. So what should I put inside this here? Aha, item is important. Okay, all the item would be A+. All the updates, yeah, maybe a little bit lower, right? But gotta be careful, right? All the item dot updates. Okay, so now why does this compile? Right? If you look at that, you know that here, all the item, what is the static type? Observer. So that means observer does support updates, so that's why it compiles. But now, how does dynamic binding work? Dynamic binding, yes?
So what's going on at runtime is because you can attach any descendant class observer to the items in the observers list.
Yes.
All of these descendants that are attached have their own implementations for notify. So at runtime, it's using polymorphism.
Yes, brilliant. That's exactly correct. Yes, that's exactly correct. So there's something called polymorphic list. So at the runtime, so let's say I got 3 observer in now. So maybe the first observer is simply current conditions. And the second observer is, let's say, forecast. I just use different color to say it's different objects dynamically. And also the third one is simply just maybe statistics, right? So now each one of them has their own update feature. So if you go a little bit further, I will show you quickly the update feature. Okay? So now you can see that, for example, in the case of, oh, you know what? Okay, I just want to show you quickly. So you can see forecast is an observer descendants. It has to define its own update. I didn't show in the slide. You can refer to the slides. Okay, current condition is also a descending class of observer. Okay, it also got its update feature as well. Okay, different versions. That's exactly right. Okay, so now when you actually call all the item, the updates, right? Dynamically. Okay, let me say this precisely. The version of updates according to the dynamic type of all the item is call. Okay, that's dynamic binding. Okay, are you okay with this? Okay, good. Okay, that's about the notified. Okay, and now one more thing to review quickly. So now, basically, if you think about the observer pattern, so this is how I will remember it. You basically got like a bidirectional links between the observer and also its subjects. So what do I mean by bidirectional? You can think about over here. Let me just show you some. Let me draw it quickly. Let's say this is some weather data subjects, right? This is the objects over here, and they got an attribute called observers, which might point to a list of observer, right? Okay, each of the observer, let's say this is the forecast. And let's put another one. Let's say this is the current condition, okay? So now for each of the observer, they also got some attributes. which is called, it could be, let's say, just called weather data, right? Weather data over here, and also weather data over here. So what do I mean by bidirectional link? Number one, you should make sure every time you're trying to create your observer objects, you should make sure their weather data field should really point to this particular subject that we're talking about, right? And also here, you should also point to over here. That's one direction. What about the other direction? You want to make sure the observer elements in the observers should also point to the corresponding elements, right? So now like this. So you got aliasing. Okay, I'll just give you one example here, just one example. You can see WD, let's say this is observer 1, okay? And this is observer 2, okay? We got two observer objects. WD.observer at position 2 is just observer 2, right? Okay, you can see the links, right? This link and this link. So these two links point to the same objects over here and also over here, okay? The same objects. Symmetrically, you can also see that O2 dot WD is referring to WD. Agree? Okay? You can see in that case, you can see O2 WD is pointing to this particular object here, and WD is also pointing to this object. So we've got two pairs of alias links over here. But now, that's conceptually what should be established. How do you do that though? Let's think about how you would do it. Let me switch back to our architecture diagram, okay? So the most important feature you should know about how the implement will be notified for subjects. So what about observer? Okay, anyone? How do we do it? If I want to define the make feature for forecast, okay? And if I want to create a forecast, I better tell you which weather data I want to get attached to, right? Weather data, let's say. Now, what should I do in order to establish that bidirectional links? What should I do? Give me one line. Weather data, let's say, yeah, attributes, yeah. Let's say we do have, so WD. Let's say weather data, I think that'll be better, weather data. Okay, let's say there's an attribute, and then? So attach and detach, so they are actually the commands for the subjects. They are not really, you know, the attributes over here. Tell me exactly what you want to write. Call attach on what? WD dot attach what? Which means the current observer, for example, forecast I'm creating, I'm attaching that object over here. For example, I'm attaching this particular object as one of the observers, right? Okay, that's one. What about another one? That's only one direction, right? We're only saying we're attaching this object here to be the first observer for the subjects. What about the other direction? Also, you want to make sure the weather data attributes also refer to exactly the same subjects, right? That's one easy. Weather data is assigned to WD, right? Okay, that's a very quick review for the observer pattern, okay? That makes sense to you? All right. Yeah. Yeah, all the design patterns are important, I would say. Yeah. Which is more important? Observer definitely is important. Visitor is also very important. Iterator may be less important, maybe, since you got tested already, right, in lab test 1. Well, that doesn't mean we cannot ask you, right? Sometimes we might ask you something that's not important, right? Yeah. Huh? What was the proof? What do you mean? Well, no. I'm saying that, well, what you should study is everything that we cover in the course, right? And we can ask you anything from there. That's my point. Yeah. We wouldn't ask you something maybe from 3101, right? Huh? No, we wouldn't. We could, but we wouldn't, right? Yes. Undo, redo, you don't have to worry. Huh? Adapter, it wasn't covered in section M. You don't have to worry.
It was in the lab.
In the lab?
They mentioned in a small section in the lab.
Oh, they did? Oh, you know what? I would say only worry for that for the lab. You don't have to worry about, since I didn't cover that explicitly in the section M, so you don't have to worry. Yep, the same exam. The same. It's going to be the same exam for both sections. Yes. Oh. Yeah, go ahead. I would say the exam for this year is better designed. Does it make sense? Me and Jonathan, we spent 2.5 days coming up with new questions. And we try to organize it in a very logical way. So I think you're going to have fun time on Friday. Maybe even more fun than lab test 1. Maybe even more fun than that. I tell you what, if I just tell you how many questions, it wouldn't help you too much. It could be that, for example, if I tell you there are 3 questions, maybe one question has 15 sub-questions, right? How many pages? Less than 25. You know, for my 1021 exam, they got 36 pages. Okay, any more questions? Yes.
When you draw a block diagram arrow on paper,
Yeah.
do you fill out the entire arrow, or you can just do it?
Oh, I see what you mean. Okay. Okay. Okay, that's good questions. Okay, just quickly. Let's say if you got one, if you got one class over here, and then you got another class here, you don't have to use red pen. That's okay, right? For inheritance, draw it like this. Okay, it'll be clear to us it's inheritance. Okay, and also usually you will draw the inheritance link vertically, right? For client supplier, this is what you can do. So that's client supplier. You can use double line arrow like this. Okay, you don't have to fill it in. You don't have to. But most importantly, for a client supplier, you should put a label here. Right? That's how we can tell. For the inheritance, don't put label. Okay. I would say unless we tell you you have to put all the attributes, otherwise just choose the most important ones. Yeah, yeah, most important one. Yeah, unless we tell you which one to put, right? Yeah. Oh, by the way, there's no two-way label. There's no. So if you really got, let's say we got client supplier, right? Let's say class A and class B. Let's say you got class A and class B, okay? Let's say we got attribute, let's say L1, okay? L1 is of type B. That's how you get an error over there, right? Let's say we got another one, let's say we got L2 of type A. In that case, you would just have to maybe draw another double line arrow like this, okay? And then you can say that's A. Don't put double arrow, there's no such syntax. Okay. Sure. Yeah, visitor pattern is very, very important. Very, very important. I'm not sure if they emphasize it enough. Very, very important. Let me just see this. Bound diagram for visitor. Okay? Yeah. What about it?
So for the descendant of a visitor,
Yeah.
let's say evaluator,
Evaluator, yeah.
since visitor constant and visitor addition, they take the class constant and addition. Shouldn't there be a client and supplier relationship?
I agree. You're basically asking the following. You're asking why did we not actually put, for example, let's say from visitor here to, okay, let's say addition. Okay, for example, I can definitely put an arrow over here, client supplier, and then I can simply say visit addition. For example, right? You're right. However, when you're doing diagram, you're not really trying to generate like an Eiffel Studio to generate 100% detail. You don't have to. It's not a good practice. You want to really select just enough level of details to show the clients. So to present to you the visitor pattern, in this case, what's really important is to see the accept from the composite to the visitor. That's most important to show. Others, we don't have to. Okay? I would say, well, let's say beyond the exam, right? Later on, if you want to show your client some design diagram, you don't have to bombard them with all the details. Only be selective. Okay? Yeah. So if you put that error there, I'm not saying it's wrong. It's actually correct. It's just not a right level of abstraction to show for the visitor.
Say we have a utility class in singleton, and almost every other class uses from the utility. How would the bond diagram look for that?
Say it again. You want to, okay, you're asking some scenario and how to draw the bond diagram, right?
Yeah.
Okay. Okay, so what do you want to have?
There's a utility class.
You,
Every other class. Yeah,
oh, I see. You want to have a utility because some singleton pattern, right? Something like this. Okay, how do we implement singleton pattern? Once, good. That's good. And also remember separation of concern, right? You want to have the data and also data access, right? So you may want to have util over here. And also you got util. Oh, by the way, you know, there are two ways to show the classes, right, in Bond. Either you can just show the ellipsis over here. That's a concise view. Or you can show the boxes over here. You can put more contracts over here, right? That's a detailed view, okay? So this is the util axis. Okay, over here, so of course you can have, let's say, for example, get, let me just say util. That's a U. Okay, that's the once routine and also end over here, right? And also, what's important for the util if you want to implement singleton pattern? Actually, I'll tell you what, expanded is not really essential. Expanded is only for the convenience that you don't have to initialize a local variable, right? Well, but if you want to put it, sure. That's not going to be wrong. But what's more important is what for singleton? Well, the invariant, where should it go? The invariant talk about. Like every time when you get the util, you get the same reference. Where should you put the invariance? Util access, I agree. Okay, let me put it first. That's good. So I have invariance. Of course, if we want you to draw the architecture diagram for a singleton, that's exactly what you're going to draw, right? You say U is U, right? Okay, now what about the util class itself? What am I missing here? Yeah, exactly. The make command, right? So if you want to say feature over here, you want to say it's exported only to util access, right? The make. So that means only this class can actually call. Okay, good. Okay, okay. Let me just go a little bit further. Okay, so now and we know that. Let's see this util access. If I got some clients over here. Okay, let's say this is the clients. Okay, there's a client over here. Let's say the client is trying to make use of the util, right? In that case, they must define. Let's say we have a test, and then it's going to have maybe some local variable that's simply just pointing to util access, right? Now, one thing to say, because util access somehow is going to oh, that's fine. Sorry. I think what I meant to say was this. There's a client supplier over here, so maybe I can have access over here. Now, if you want to show expanded, okay. We know that this one also refers to this as a client, right? Okay, so now that's expanded. So now, how do you draw expanded? Straight line? Yeah, like this. Okay, make sure. Okay, you know that. And I'm not sure I'm answering the question yet, but maybe not yet. You're saying you got many other classes which will use it. Okay, so now what you should do is, so maybe you got another cluster of classes over here. Let's say a class 1, class 2, class 3. All of them are trying to use util. What you can do is, you can draw at a package level, you have a client supplier over here. Okay? They're simply using util, like this. Okay? That means every class is a client of the util. Yeah, you can also do that too. Yeah. Okay. Yes. Yes. Yeah. That's about the point for the singleton access, right? Yeah. Actually, you know what? You can, to be really 100% correct. Okay. Let me show you what I mean. Let's say this is class A, right? When you have class A, so now what you will have is, let's say U is of type util. Okay, attribute, right? As soon as you have this, that means you must have this particular client supply, agree? Okay, util. But now, the way we get the reference for this, let's say we have a make feature over here, okay? The way we do it is we can say local, and also util access, okay? Let's say access over here. Util access over here, I will say do and end. And then over here, I can say util is assigned to access dot u. So in some way, I'm also using the access class, util access. So if I really want, I can also put it like that. Okay, that's going to be the util access, if I want to. Okay. However, in this case, it may not be so recommended because you can see this is a local variable. You may not want to reveal the local information to the client, but it's up to your judgment. Okay. Yes. Which one? Oh, I mean here. It's expanded. Any other questions? Yes. Yeah, of course I can. Guys, are all of you confident with the exam? No? Do you want another review? You want? Okay. Tomorrow, 1 to 3 p.m.? I will send a Moodle announcement to you. So tomorrow, 1 p.m. to 3 p.m. It's the life science building. I forgot the roll number. I will confirm with you. Do you know where the life science building is? The kind of behind the chemistry building. Nice room. I forgot it's 10 something. I'll confirm with you on Moodle. Okay? Feel free to come. But for visitor. Okay. So now for visitor over here, okay, so if you talk about visitor pattern, so you must understand open-close principle, right? Open-close principle. What is that? There's structure, there's operation, right? Yeah, so this is for the visitor pattern, okay? Open-close principle talks about something that's more general, okay? So open-close principle is very easy. It tells that for you as a designer, some part of your system must be closed and some part must be open. It's easy as that, okay? In the specific case for the visitor pattern, if you want to support it, the structure part, the composite, must be closed. And the visitor part can be open. Okay, that's for that particular case. So it's different. If we ask you about what is open-close principle in general, you want to say something different, right? If we ask you about how is the open-close principle satisfied in the visitor pattern, it's going to be answered differently. You want to say the visitor pattern satisfies the open-close principle because over here, well, let's try this. Let me just talk about something quickly, and then I'll go over a little bit more detail for the visitor in just a moment. So every time, if you want to judge whether or not your design is good or bad, right? Think about extension or changes on your design. Let's think about two possible changes, okay? Change number one. Let's say at the moment we got constant and also we got additions. Let's say these are the only two expression components we have. So constant is simple, addition is recursive, right? Change number one, okay? Let's say I want to add a new structure components. For example, let's say I want to add multiplication. Would that be considered as a good operation? Well, when I say good, it's going to violate any design principle if I try to modify the structure in this case. First of all, is it good or bad? Bad? Oh, but I'm just saying, according to the architecture for the visitor pattern here, now the change is I want to add a multiplication class, right, to this cluster over here. Would that be considered as a good change or bad change? That's what I meant. Good change or bad change? Bad change. Okay, what principle does it violate? Single choice principle, right? Okay. So now, why does it violate single choice principle? Okay, it's really important. Okay. Why? Why is that? Well, let's try this. If I want to add a new class called multiplication, I will add it here, right? Multiplication over here. Okay, multiple inheritance. Okay, add this class over here, but what else do I have to do? Just somebody, otherwise I cannot tell. Okay, yes.
You have to make changes in all of the different
Visitor classes. Yeah, exactly. Okay, in that case, I have to add, for example, visit multiplication over here, and also visit multiplication, and also visit multiplication, right? Okay, that's multiple places you have to modify. So that violates single choice principle. Single choice principle tells you that if you make a change to your design, there should be either a single place or the minimum number of places possible that you should modify. Okay, good. So now that's not good. Okay, that's not a good change. Let's talk about change number two. Let's say change number two. Let's say currently we got evaluator, we got pretty printer, we got type checker. Let's say we got code generator. How about that? Add a new operation. Okay, let's say code generator. So now, would that be considered a good change or bad change for visitor pattern? Good change. Okay. Well, how? Okay, it seems like only one place to change, right? What exactly should be changed? Add a new class where? Over here, right? Okay. Add it over here is a descendants, I'll say code generator. And then every visit feature can be added just to this particular class. It's a single place. Okay, single choice principle. Okay. And that's about, do you think that's enough or you want more? Yeah. Well, I think what I just said was important. Anything else that's important? You may want to review, for lab number 5, exactly how you can, for example, let's say this, right? You want to be familiar with, let's say I want to create, let's say addition, let's say over here, let's say constant, and 2 and 3. How many, I guess for section Z, you haven't taken 2001, have you? Okay, there's something called context-free grammar. Any of you is going to take 4th year courses later? Nobody? Are you going to take any fourth year course later? Any one of you? That's a plan, right? There is a course called Compilers and Interpreters. That one's a fun course. And even more fun, I'm going to teach it. For those of you who are interested, you can take it. Yeah, I don't want it to be canceled. Yeah. Okay, anyway. For those of you who didn't take 2001, that's okay. It's not required. So if I want to create this particular composite structure, this is the code I have to write, right? I want to make sure you create a constant, you create an addition, etc., right? Just add it. You want to be comfortable with doing that. And then you want to say add the accept, right? That's something you also want to know how to write. You want to know how to write the accept over here. Yes, okay. Yes. Yes, oh, double dispatch, yes. Yeah, that's good. How about we review that quickly? Yeah, you're right, I forgot about that, yes. And I think, let me just copy that quickly, okay? Let's talk about double dispatch. How can you talk about visitor without talking about double dispatch? Let me grab it for you. I think, yeah, it's exactly here. Okay, and then I'm going to do over here. Okay, let's say that's the visitor pattern, okay? Let's do that quickly, okay? Basically, you got your composite over here, you got constant, you also got addition, right? And because addition is a composite component, you got expression and composite, multiple inheritance, right? You should know how to do a multiple inheritance to the extent that we cover in the class. And also, you got visitor, which got visit constant, visit addition, also got evaluator, okay? And for the evaluator, the number of visit features you have correspond to how many components for the expression you have, right? You got visit, constant, and visit addition, right? For the visit, constant is very easy. It's just base case, okay? For visit addition, you have to use some sub, like an auxiliary evaluators. Basically, the way visitor works is very similar to how you traverse recursively on a tree, basically, okay? If you try to trace it at the runtime, okay? I wouldn't do the tracing for today. If you want, you can review the slide. If you want me to do the tracing, I can do it tomorrow. But for now, I want to talk about double dispatch quickly, okay? So now let's say this. Let's say we already got the following composite. Let's say it's called add. Add is simply just addition, which got left and right. And then we got left is a constant of value 1, and right is a constant of value 2. So now I want to really call the visitor so that I'm going to get the addition, which will be 3, right? So now, this is the one-line solution to it. I just got to say add dot accept, and then v. What's v? By the way, v is simply just an object of type evaluator. Okay? So you have everything you need. So now, what's double dispatch? What's the first dispatch? Okay, I will help you to start with. First dispatch. Basically, you can think about when we say double dispatch, that means we got 2 instances of applying dynamic binding. What's the first instance? Accept? Okay, based on the dynamic type of what? I heard add and v or add. For those of you who think that should be v, you're in big trouble. You better review your visitor pattern, okay? Okay. Well, thinking this way, if you're trying to call this feature over here, make this such a method or feature call, how exactly is it going to be determined? I want to know which accept I really want to call. It depends on the dynamic type of add before I ever get to consider v, right? That's kind of the logical order, okay? First dispatch, dynamic type of add, the context object over here. Sorry, let me write it more properly. Of add is addition. So that means you will call the accept in addition. Okay, I'll just say addition here. So what is that exactly? Let's highlight it. So addition, accept is here. Okay, that will be called. Okay, so now that will be the first dispatch, which means depending on the dynamic type of the composite, you're going to call the corresponding version of the accept. Okay, that's the first dispatch. Okay, so now what about second dispatch? V, right? Okay, so now that will be V. How exactly? Now we know that we are here. This is a starting point for second dispatch. So now how exactly is second dispatch going to occur? How exactly? Anyone? Yeah. Okay, good. So now let's give you a little bit more context here. So now in this case, it's actually V, right? So that means the visitor here is simply just V. What's V? Evaluator. So now you want to plug in what you just said. So now in this case, you can see that the V over here is now becomes the context object, right? Always, if you want to talk about dynamic binding, you want to talk about what a context object is. In this case, V, dynamic type of V over here is evaluator, okay? So now you will call the visit addition. Visit addition in evaluator. Okay, in that case, you will get this. So this guy here is from the first dispatch. This guy here is from the second dispatch, right? Two dispatch. Right, so that's the most one of the most important features for visitor pattern. No, when we say double dispatch, you want to we will be very clear when we give to you. For example, we want to say consider this particular use of the visitor pattern. In that case, of course, the first dispatch cannot be V, because the execution order you start with the add first, and then the V, right? Mm-hmm.
If add is already, like, we know that if its static type is already addition, would it still be considered a double dispatch?
It will be, actually. I think that's a good question. You're basically asking the following. You're basically asking, we got two options over here. Okay, option number one, if you declare add to be expression, let's say, expression is the top level deferred type, right? You can say creates addition, I'll just say add, addition add dot make. So now if you try to call add over here, static type is simply expression. Dynamic type is just addition, right? Let's talk about option 2 that you just mentioned. The answer is it doesn't make a difference because in the following sense. If I say option 2, now if I say add, it's simply declared to be addition. And then over here, I can say creates. Now what should be the dynamic type? You can see the addition here is not the dynamic type, it's just a static type, right? So now I can say addition, just the same. And in Eiffel, if the static type and the dynamic type are the same, you can ignore this part, right? So now in this case, add.make is going to create add, where static type is simply addition, but dynamic type is just the same. So now if you try to call add.accept, the same idea, right? Yeah, exactly, yeah. My point is, in the two options over there, they're both compile. It's just a matter of when you declare the attributes, do you want to make an expression or addition? Yeah. Any other questions? Or you can study more and then ask me again tomorrow. Okay, life science building, I'll confirm with you the roll number. Okay, it's from 1 p.m. to 3 p.m. You got more questions? I can answer, yes. Open close principle. Okay, I'll see you tomorrow. Okay, just come.